let's talk about hyperbolic functions. So what is a hyperbola? A hyperbola, hyperbolic functions, So hyperbolic functions, they are defined by y is equals to a over x plus p plus q. So this is the driving force, and this and this. So when a is greater than 0, we are going to remember that it's quadrant. It's quad 1 and 3, right? So it's going to look like this. It's going to look like that. And then if a is less than 0, so it's quad 2 and 4, right? So it's going to be quad 2 like that and 4 like that. So for hyperbolic functions, they revolve around this whole concept. They revolve around this whole thing. Instead of they move this side, they move up, they move down, they move left, they move right. But they are revolving around this. At the end of the day, we are coming back to this. Whatever that you're going to be doing, it comes back to this part. So how do we know? How do we solve quadratic hyperbolic functions? All right, so number one, you have to know that q represents q is equals to what? The vertical translation. Number two, p represents the horizontal translation. What does it mean? So q, this is all about the vertical asymptote. And then p represents the horizontal asymptote, right? So number one, let's talk about this. For example, we have y is equals to a over x. So our a over x and p in this case is going to be 0 and q is equals to 0. Case number one. So when p is equals to 0 and q is equals to 0, the vertical asymptote, alright, let me write it here. The vertical asymptote is equals to the y-axis, which means that x is equals to 0. Number two, the horizontal asymptote, which is our p, is equals to 0, and x-axis is the one that is represented, which means that y is equals to 0, like that. So number three, the axis of symmetry. It means to say that y is equals to x and y is equals to minus x. So this is case number one, right? And then case number two. Oh, okay. And then the domain, x is an element of real numbers, and then the range is going to be y is an element of real numbers, and y is not equal to 0. And then in this case, x is also not equal to 0, right? So that it can be defined. Because if 0 is there, then it means that it's not going to be defined. So you won't have something that is going to be defined there. So at the end of the day, we have that, right? And then let's talk about case number 2, right? So case number 1, we did it, and then case number 2. Case number 2 is when we have we don't have P, but we actually have Q. Okay, so we are going to add a Q there. So what changes? The changes that are going to be there, P is going to be 0, so the vertical asymptote is still the same, right? And then the horizontal asymptote now is going to be, the horizontal asymptote now is going to be Q. Y is equals to Q, right? And then number 3, we are going to have the axis of symmetry. It's no longer x, it's just going to be y is equals to x plus q, and then y is equals to minus x plus q, right? And then the domain and the range, they are going to change. Now x is an element of real numbers, this is the same, but now for the y part, we're not going to have 0 there, we are going to have q. So that's the difference that we have when we have case number 2. When we include a q there, when we include a q part in this point, we are going to have that as the difference. Okay, what if we add a p? So instead of having x, we have x plus p. So this would give us case number 3. So case number 3, what changes? The p part, the p part is going to change in this case, right? In this case, p is equals to 0, and then q, y is equals to q for case number 2. Y is equals to q for case number 2. And then for case number 3, what is going to change is the fact that for the vertical asymptote, we are going to have x is equals to minus p. Vertical asymptote, x is equals to minus p. Okay, let me rub this. Let me rub this so that you remember. So for case number 3, the horizontal asymptote changes, the vertical asymptote changes, and the axes of symmetry, they also change, right? And the domain and the range, they'll also change. So what is the big difference that we have? The vertical asymptote, number 1, remember here we have x plus q plus p, right? So for us to get the vertical asymptote, what do? We are going to equate this to 0, right? So we're going to say x plus p is equals to 0. So if you take this p to that side, it's going to be x is equals to negative p, right? So now that you have that, so your vertical asymptote, x is going to be equal to negative p. And then for the horizontal asymptote, y will be equal to q. It will still be the same, right? And then the axes of symmetry, they are going to be 2. So number 1, y is equals to x plus q, and then y is equals to minus x plus q, like that, right? That's the other difference that we have there. So right, that's the difference that we have there. And then the axis of symmetry, and then the domain is going to be the same, x is equals to minus p, and then the range is also going to be the same, y is not equals to what? Q. So that's what we have there. So at the end of the day, this is the information that will be changing, but I've also uploaded the pictures for the documents, so you still have access to them. Make sure you get to understand this, the domain, the range, or the asymptotes for the hyperbolic functions. So in other cases, you can find that the gradient is there. You can actually use it to find the asymptotes. You can actually use it to get to find the axis of symmetry. It also works in that way. So let me know if you have any questions, and I'll be there to provide the answers. And if you are in need of a tutor, please let me know. We are here to help you, and we also offer group sessions. If you need group sessions and you're around Pretoria, we can come to your place, or we can meet around Pretoria Central, and we have our tutor sessions. So book a class and we'll be there to help you. First time people, you're going to get a discount. So come through and find out how best we can help each other. Bye.